We'll proceed on calculating the minimum, maxima, or rather critical or extreme point. So we were doing things in 2D and we'll finish 2D and then we'll continue for the 3D. Okay, then beyond that, there are things that are very, very important. So put your head in this discussion. So that is required. Now, the idea is that if I have a function fx y equal to fx and if I calculate the differentiation f dash x f single quote x or dfx by dx, okay, then if the differentiation is zero, differentiation rate in change. So we started discussion with the collection of kilometers. A person is walking and he starts from a zero location, zero time, and then he is walking at a particular speed. If I say particular speed in the sense that per hour he is collecting kilometers. So speed means what is the collection, how many kilometer collection per hour, rate of collection per hour. So if I have rate of collection per hour and I want the net collection, then I have to do integration in the sense I have to calculate the area underneath and that area is the integral part. So integration is nothing but if I have algebraic equation from one boundary to another boundary, if this is x-axis and this is algebraic equation, then one boundary to another boundary. If I am able to get the area, that area is the net collection, whereas the algebraic equation is rate of collection. If I have rate of collection and if I calculate the area, then I get the collection through integration. That's why it is the basic of the calculus. But if I have the collection over a period of time and I want rate of collection, opposite, then it is differentiation. So this is what we saw. Now we took the example of parabola. So y equal to kx square, where k is constant. If I keep k as 1, then y equal to x square. So rate of collection is per hour. So we took t instead of x. So y equal to t square. If y equal to t square, then its differentiation is 2t. If differentiation is 2t, then differentiation, the rate of change that we are seeing, the rate of change, there is rate of change when there is a parabola. So parabola is like this. This is parabola. In between, this is y-axis and this is x-axis. So wherever parabola comes to a stage where it starts increasing, that point is origin. This is what we saw. Y equal to t square. When t equal to 0, y is 0. dy by dt equal to 2t. If t is equal to 0, then dy by dt is also 0. Or I can shift this. If this is parabola, then full parabola, I can shift little bit right. Then it will be like y equal to t minus 2 whole square. Then we have shifted 2 along the x positive x-axis. T minus 2 whole square. If that is the case, t minus 2 whole square, then if I try dy by dt, then it will come as 2t minus 4. Now dy by dt should be 0. If dy by dt should be 0, to calculate the minimum or maximum, then t equal to 2. If t equal to 2 means this parabola is the rate of change is 0. Rate of change is 0 when t equal to 2. Prior to that, the rate of change is negative and after that it is positive. This is what we discussed. Now, we will take this discussion to calculation of the maxima and minima. Maxima or minima is a point in the curve where the first derivative is 0. There is no rate of change. There is no change in the kind of rate of the collection. If there is a person is walking in a fashion, that graph is like this parabola. with time is negative, then his speed is decreasing. Okay, and it reaches 0 and then its speed is increasing. So the dy by dt is negative because if I do dy by dt means if there is a unit change across t axis, x axis, how many unit change along the dependent component, that is y. If I move in this direction and graph is like this, then if there is a positive change, then the vertical side is going down. So dy by dt is negative. It will negative, negative, negative as per parabola. It will come to a stage where it will start becoming positive. That stage, so dy by dt is negative, 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 negativity is going low, 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 and slowly it will become 0. And then it will rise the, so dy by dt would rise. Where it is becoming 0 at t equal to 2, when y equal to t minus 2 whole square. At t equal to 0, when y equal to t square. So it depends upon the kind of what is the algebraic equation. Now we understood this, that when the, so if I see the curve, and here when curve is taking tilt and going in positive direction, if that tilt, okay, that tilt, the rate of change, at first it was negative, negative, and that negativity is decreasing, see, and slowly it becomes flat. Flat means there is no rate of change. If I increase along x-axis, then y-axis won't increase. That is rate of change is 0. If it is like this, rate of change is like this, means if I increase along x-axis, rate per unit change, if I make along x-axis, then per unit change, then number of unit change along y-axis is not there. So that's why it is flat. Then it is grow like. Now if it is growing like this, if there is 1 unit of change along x-axis, it brings some unit of change along y-axis. But when it's turning, there it is flat means, so the dy by dx, dy by dt, the first derivative differential, if it is 0, then either it is minimum, or curve is, parabola is like this, then there also parabola is like this, then on top also the dy by dt is 0, but it is maximum. Or if it is a cone, if it is a cone, it is going like this and sharply it is coming like this. So there is no point here, potential. If it is a parabola, it is going like this, and there are few points are there, then it is coming like this. If it is a cone, sharp, then sharp. Okay, there is no point. So if I calculate, if I kind of the, even though if I get a time where the first derivative is 0, but there it is the dy by dt, it is called undefined. Okay, but it is also an extreme point. If I set dy by dt as 0 and t I get as undefined, okay, then it is also considered an extreme point. So actually we are talking about extreme points, okay, critical points, not minima or maxima. So it extreme points where dy by dt is 0, it can be minimum, it can be maximum, it can be undefined, or in two-dimensional, in 3D, this is 2D, in 3D we will see the saddle points also. Okay, now these are the things that we would see when we consider the, we are talking about the minima and maxima. Okay, now take the concept of sine wave. The sine wave is sine t, y equal to sine t. When t equal to 0, then y is 0. When t equal to 90 degree, pi by 2, then if t equal to 0, pi by 2, then sine is 1. If t equal to pi, then sine is 0 again. If t equal to minus pi by 2, then it is minus 1. T equal to minus pi, then it is 0 again. Now we also discussed that there is something called local minima and global local minima, local maxima, global maxima. Now if we see the sine wave, so if it is x-axis and this is y-axis, so from negative it reaches the origin, so and then it crosses the origin and it becomes maximum. Then it touches the 0 on x-axis again. So it intercepts x-axis at pi. If I go back at pi by 2, it is maximum. If you go back to origin, means again intersection of x-axis and y-axis, it is 0. Then it goes in negative direction and it is coming back again to 0. Now if I create a region between minus pi to pi where it is not including minus pi and pi. So there is a region where there is a path boundary. Okay, so if there is a region, if there is a region and region is bounded by a path boundary, inside the region, what is the situation? If I take a region minus pi to plus pi, where plus pi and minus pi there is a path, and inside that, so where greater to minus pi and less to pi, not including minus pi and pi, then if I draw the sine wave, then it is like at minus pi by 2 and pi by 2, minus pi by 2 and pi by 2. There are minimum and maximum. At minus pi by 2, it is minus 1, and pi by 2, it is plus 1. So, but if I go beyond the region, then again it is repeated. It means it is kind of, it would repeat. So it is like this. Okay, if that is the case, then minima mix maxima minima maxima in with this direction, in this direction, everywhere it would keep happening. So in a region when I have one maxima and one minima, then it is called local maxima and local minima. So if sine t is the equation, then if I do the first derivative, it becomes cos t. So if I say cos t, then when cos t becomes 0, cos t becomes 0 when t is pi by 2 or minus pi by 2. So at t, when t is pi by 2, when t is minus pi by 2, cos t, that is the differentiation of sine t, the cos t is 0. If that is the case, then it is maximum or minimum. Okay, or means it is a critical point. It can be maximum, it can be minimum, or it can be something that neither maximum nor minimum. Okay, in 3D we will see saddle point. Now let's calculate what it is. So if I want to know what it is maximum or minimum, then little bit before the point, the t, will see the value, and after this we'll see the value. If cos 90 degree, cos pi by 2 is 0, then what about little bit I go left, like cos 80 degree. If it is 90 degree 0, cos 80. Cos 80 degree is some positive value. Some positive value. And then cos 100 degree is again some positive value. So if that, I'll go with the actual equation. So through the differentiation, I could find that cos t means t, when pi by 2 it is maxima, and when t is minus pi by 2, when t is pi by 2 it is extreme point, when t is minus pi by 2 it is extreme point. I don't know it is maximum or minimum. So the actual equation is sine t. So sine t is the y equal to sine t. Differentiation of sine t is cos t. Now sine t, when it is pi by 2, the value is 1. When sine 80 degree is there, then value is less than 1. When sine 100 degree is there, value is less than 1. If that is the condition, this proves that this is maxima when pi by 2. Okay, now minus pi by 2. Minus pi by 2, sine minus pi by 2 is minus 1. So minus 90 degree or 270 degree. 270 degree. So minus 90 degree. If it is minus 80 degree, then it is more, it is towards going towards the x-axis. So it is more than minus 1. If it is minus 100 degree, then again it is more than minus 1. So it is minimum at minus pi by 2. So the maximum we could trace, that is pi by 2, and minimum we could trace, that is minus pi by 2. So how we have to calculate maxima and minima is that first we differentiate it, then we equate it to 0, and then with the independent variable we find the independent variable, that is t, that at what value the differentiation is 0. If that is the case, then t equal to That point is the extreme point or critical point. Now we take back the equation, and at that t prior to the t and post t, we calculate the dependent variable or the function value, like sine t. At t less than pi by 2, greater than pi by 2, what is sine t? Now minus pi by 2, less than minus pi by 2, and greater than minus pi by 2, we calculate. And with that, we understand that it is either a maxima or minimum. So easy, right? So critical points are point where differentiation rate of change of collection is zero. Okay. So if we see rate of collection as tangential line, now now this is sine wave. Okay, so if this is negative and this is passing through origin, then this is sine wave. If this is sine wave, then this is origin and this is minus 1 and this is plus 1. So this is kind of sine wave. If this is a kind of a sine wave, then if it is extreme, now if we see the rate of collection, then that is a tangential line. So rate of collection, if we are calculating, then it is a everywhere rate of collection. Okay, so this is my sine wave. So rate of collection everywhere is tangential. So if it is like this, then dy by dt is positive, but it is slowly it is becoming zero. Zero means there is no, if I move little bit along x-axis, dy by dt is delta y by delta t. If there is a delta t, 1 unit change, then how much y is changing? That is delta y by delta t. If at this point, if I make a small change along x-axis, then along y-axis there is no change because it is a flat line. So flat means there is no change along the vertical, but slowly there will be negative change. So if it is negative change is there, and then it is no change, and if there is a positive change, then also I can find it is minima or maxima. And same thing here. So tangential is like this, then it is becoming flat here, and then it is like. So one thing I said that sine t differentiation is cos t. So the cos t value is 0 when t equal to 0. If t is pi by 2, prior to that 80 degree. What is cos 80 degree? So cos 80 degree is positive, and cos 100 degree. So cos 100 degree means, okay, so if cos 0 degree is 1, then from 1 it is decreasing and it is going to 0. Okay, that is cos pi by 2. Now, if I go beyond cos pi by 2, then kind of it would become negative. This is what I am thinking. So one side it is positive and other side it is negative. So positive to negative it is going. So something different, right? This positive, one side it is dy by dt is positive, other side it is negative, and in between it is 0. Consider if that is the case, then it is maximum. If I take the minima here, sine wave is going like this, then if it is going down means first it is negative, then it is going positive. If it is negative and then going positive, then it is minima. If it is positive and going negative, then it is maxima. This way also we can calculate the minima and maxima, or we'll take the straightforward the line equation, that is y equal to sine t. And then we'll see at that point, before this point, what is the y, and after this point what is the y. If y are less than that point, means it is maxima, or greater than that point, then it is minimum. So this is what we are calculating. Okay. Now situation is that with dy by dx we can calculate it is maxima or minima. With function also we can calculate it is maxima or minima. Is there any programmatical way? I don't want to go to the equation cos t or sin t and check prior value and then think that, okay, so mathematics is where you have to keep your brain on the table aside. the machine work. That is the mathematics. M for machine and M for mathematics. So machine now is replacing your mind. So machine should do everything, not you. So it's time to have fruit, or it's time to kind of go for a walk, or it's time to have tea or coffee. So it's a time for break. Let the machine work. That is the your brain replica is placed inside the machine. That is the idea. Now you are working, machine is working, then you are working, machine is working. That is not the motto of mathematics. So mathematics is different. Now, if I have a differentiation that is zero, then if I want to know that this extreme point is maxima or minima, then left side of the equation, right of the equation, then we see, then we decide it is maxima or minima, or left side of the differentiation, right side of the differentiation, we check, then we decide for the maximum. This is what is not required. So can we do some mathematics again that quickly I can find out with algebra that it is maxima or it is minima. Okay, now let's see the case of sine wave again. Now if it is sine wave, the sine wave, if it is minus pi by 2, it is minima. Extreme point, then it is going like this and crossing the 0, 0 origin. Then it is going again, and at pi by 2, it is making the critical point again, and it is going back to pi. Okay, and this is local maxima, local critical point. This is also a local critical point, because we are taking a region between minus pi and pi, excluding minus pi and pi. Now if this is the case, then let's see this part at pi by 2, where it is going like this, and pi by 2 it is turning. If that is the case, then the differentiation is cos t. If differentiation is cos t, then when t equal to pi by 2, the derivative is 0. Can we draw a derivative graph? No one stops us, right? Derivative graph. So if this is the equation of sine wave, if this is the equation of sine wave, then if this is the equation, okay, oops, if this is the equation of, if this is the if this is the equation of sine wave, then here the dy by dt is positive, here 0, and dy by dt is negative, because if we grow in x-axis, then y is going down. Now if I draw the graph of dy by dt, then if it is x-axis and this is y-axis, so origin, okay, if it is pi by 2, means if center is pi by 2, center is pi by 2, where kind of where the dy by dt, if t is pi by 2, then dy by dt is 0. Okay, consider the origin is pi, for time being origin is pi by 2. Prior to that, differentiation is positive. Can we see? if this is if this is x-axis, if this is x-axis, and this is y-axis, this is y-axis, you can see me, this is y-axis and this is x-axis, then this is the origin. Okay, now I am drawing dy by dt, that is cos t. Now consider that here pi by 2 is there, this is pi by 2 origin, this is pi by 2, somehow mix it, we will see the actual. And then be, beyond pi by 2, beyond the pi by 2, the derivative is negative. So okay, so it is this, if this is x-axis, then if it is pi by 2, now consider this is pi by 2, if this is x-axis, then this is pi by 2, beyond pi by 2 it is negative, so it is somewhere here negative, but beyond pi by 2, but prior to the pi by 2 it is positive. So a line, the dy by dt is a line that is coming from positive. At pi by 2, it is going 0, and beyond pi by 2, it is becoming negative. Straightforward. Right? If the sine wave, if sine wave is like this, 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 then at pi by 2, prior to pi by 2 dy by dt is positive, it is 0 and negative. So if this is x-axis and this is y-axis, and somewhere on the x-axis we have pi by 2, t equal to pi by 2. So prior to pi by 2 in this direction, it is positive dy by dt. But at pi by 2 it is coming as 0 and then it is going as negative down. So dy by dt is something like this. If this is pi by 2, then prior to the pi by 2 dy by dt is positive. Then at pi by 2 it is becoming 0 and then it is going as negative. It is coming like this graph. Now, if I consider dy by dt as a graph, then at pi by 2, what is d square ty by dt square? Means if there is a function called gt, if there is a function called gt and gt equal to dy by dt, okay, ft is y, okay, y equal to ft, then dy by dt is gt. So gt equal to cos t. First derivative is gt, that is cos t. dy by dt equal to gt equal to cos t. What is dg by dt? Double derivative, dg by dt. If I have a simple, forget the part derivation, I would say I have a graph and equation is cos t. If I say it is cos t, equation is cos t, then it is positive, okay, it is coming as positive, and when it is pi by 2 at this point, then it is becoming 0 and beyond that it is becoming negative. Now, if I differentiate it, then can we see this? If I differentiate this, then prior to the pi by 2, it is negative. Differentiation prior to pi by 2, is it? It is negative. Then it is going down, it is again negative. Okay, it is coming like this, positive, and then at pi by 2 it is becoming 0, then again going down like this. So at pi by 2 the slope is negative. So dy by dt, dg by dt, or d2y by dt square, double differentiation. When it is negative, then it is maxima. When it is positive, now we had taken the original sine wave. If original sine wave means at minus pi by 2, it is again there is one extreme point at minus pi by 2. So now the derivative of sine t is cos t. If derivative of sine t is cos t, then at minus pi by 2, the cos t is minus 1. Okay, so now we have forgotten everything. Now idea is that we will calculate blindly the what we have seen now. If the double differentiation is negative at that point, then it is maxima. Now can I consider that if it is positive, then it is minima? Let's see. Now at minima is at minus pi by 2 and dy by dt is cos t. Now, if that is the case, then at pi by 2, when it is minima, prior to the pi by 2, dy by dt is negative, and after the pi by 2, dy by dt is positive. So, it is first it is negative. Now, if this is x-axis, then below x-axis, negative. So, before pi by 2, it is negative, then it is crossing the origin here at minus pi by 2. Before minus pi by 2, the value dy by dt is negative. When it is crossing, this explanation is not available in any of the book. People would say something, sir. This kind of explanation is not taken from any of them. Okay, so if this is x-axis, and if this is minus pi by 2, prior to minus pi by 2, the value is dy by dt is negative. Now it is crossing the origin, it is crossing the intersection, making it is at minus pi by 2. Beyond minus pi by 2, it is becoming positive. If I take sine wave, the original sine wave, then it is like this. Then this is minus pi by 2. Prior to the minus pi by 2, the dy by dt is negative. And after the pi by 2, dy by dt is positive. So if I draw the graph of dy by dt, that is gt, then if this is x-axis and this is minus pi by 2, then prior to minus pi by 2, it is negative. It is crossing the pi by 2 at the x-axis, and then after crossing, then it becomes positive. So it is something like this, coming from negative, crossing the minus pi by 2, making intersection on the x-axis, and then it is going like this. So at minus pi by 2, when it is crossing the x-axis, there the slope is positive. If d2y by dt square or dgt by dg by dt, the second derivative is positive, means it is minima. If second derivative is negative, then it is maximum. Okay, so this is the concept of maxima and minima. Now you can put your brain aside, have coffee and tea, or go for a walk, and let the machine calculate, decide it is maxima or minima. First it will make it a derivative, single derivative, and then it will check for zero, and it will get the t value, and that t value again it will calculate the second derivative, and it will check for that t value, and if it is negative, then it is maxima, and if it is positive, then it is minimum. So this is the idea of second derivative. Let's try when y equal to t square. When y equal to t square, then parabola is like this. It is a parabola, and it is like this. Now this parabola, this side it is going to grow infinite, this side it is going to grow infinite, except apart from any region I am taking. So this is global critical point. Okay, because this is only one critical point we are saying. Beyond that, it will go infinite. So in sine wave, we talked about local critical, because if I go beyond minus pi and pi, then it will keep repeating. But here it won't repeat, will go. So this is local critical point and global critical point every. But in sine wave, if I go for global, there will be many critical points. Anyway, now y equal to t square. Then first derivative is 2t. When 2t equal to 0 means at t equal to 0, then I have the critical point. So when t equal to 0, then this is a critical point, because dy by dt is becoming flat, means there is no rate of change. If I do double differentiation, it is 2 positive, means it is global, it is minima. Okay, if I take equation as minus t square, then it is like this, opposite. If it t square, then minus means opposite. If it is opposite, then first derivative is minus 2t. If I set it to 0, t equal to 0. If I take second derivative, then minus 2. If it is minus means it is, if it is minus means it is maximum. If it is plus means it is minimum. Simple. If I take shifted parabola, that is t minus 2 whole square, then first derivative is 2t minus 4. So t equal to 2. When t equal to 2, then it is derivative is 0. Okay. Now when it is a t equal to 2. Okay. So kind of when t equal to, so our equation is t minus 2 whole square. So first derivative is 2 t minus 2. When t equal to, okay, first derivative is t minus 2. Okay, so when t equal to 2, then first derivative is 0. So at t equal to 2, first derivative is 0. So t equal to 2 is the critical. Now I'll go for second derivative, that is 2. Anyway it is positive. So when t equal to 2, it is minima. Now second, if I take minus and in bracket t minus 2 whole square, then this is the parabola and shifted along x-axis 2. First derivative is minus 2t plus 4. Then t equal to minus minus uh, t minus 2 whole square we have taken. Now it will come as minus 2t plus 4. Then it will become t equal to minus t, minus t minus 2 to the power 2 whole square. So we are expecting that it is opposite way. This is the equation. Now kind of when t equal to 2, it is 0. When t equal to 0, okay, when t equal to 0, then it is minus 4. So when t equal to 0, it is minus 4. First derivative is minus and then 2t minus 4. Okay, then it will become minus 2t plus 4. Then t equal to something. Okay, we will get t equal to something. So if t equal to something, so okay, so it will become t equal to 2 again. This is what I wanted. So t equal to 2. Now I go for second derivative and that is negative. So second derivative is negative means it is again maximum. So second derivative is positive, then it is minimum. So when t equal to 2, so what we did, we took the upside down parabola, that is minus t minus 2 whole square, where it is shifted 2 in the along the x-axis, and then we do the second derivation and it is minus, so it is max. So this is the idea of calculating the maxima or minima through the double derivative. Okay. Now we'll proceed with the 2D. So 2D, okay. So 2D is something like I have a plane now. So 2D, I have two independent variables, x and y. Earlier we had independent variable t or x, only one independent variable, and y equal to fx. Now z equal to fxy. There are two independent variables, x and y, and this is the xy plane. So x-axis is replaced by xy plane, y-axis is replaced by z-axis, and x-axis is xy plane. If that is the case, xy plane, then we can have various graphs like parabola we were taking. So parabola we were taking like this. Now if I rotate this, then it becomes a paraboloid. Parabola becomes a paraboloid. So equation will be fxy equal to x square plus y. One equation. If this paraboloid is upside down, then fxy equal to minus and then in bracket x square plus y. Okay. If the paraboloid is shifted 2 along the x-axis and 1 along the y-axis, or 1 along the x-axis and 2 along the y-axis. If this is paraboloid where the top is origin, okay, and if I shift 1 along x-axis and 2 along y-axis, now here is the paraboloid. So fxy equal to x minus 1 whole square plus y minus 2 whole square, because this is the shift we made. If it is, I mean this parabola, shifted like this. If this parabola you want to shift, then equation is minus and then bracket x square plus y square. This is tilted parabola. Then it will be minus and in braces x minus 1 whole square plus y minus 2 whole square. Then if I have a cone, okay, if I have a cone, this is equation of a cone. I mean it will be sharp. Okay, so this is equation of a cone, sharp end, and now we rotate round, it becomes a cone. If it is a cone, then equation will be fxy equal to square root x square plus y square, because everywhere in every cross section it is a circle. X square plus y square square root, that is equation of a circle. So cone is at the center, there is no point, and if I grow along x-axis, y-axis, then altitude will also start growing, and it is keep forming circle at every altitude. Circle, the way x and y is growing, circle is bigger, becoming bigger, and it is growing in the height also. So the cone equation is x square plus y square square root. If I have a tilted cone, then it is my x square plus y square square. If I have a tilted cone upside down, then minus square root x square plus y. So these are the equation in the 3D formation. Okay, there can be other equation also. So probably then we will see that how we can calculate now extreme point. So there can be extreme point in 3D. Like there is a surface, there you can imagine as a surface. So if this is xy plane, and at each xy point there is a vertical point, that is fxy equal to fxy, z equal to fxy, where fxy equal to x square plus y square square root. So for each point on xy, on the xy plane, there is a vertical point. If I connect all the vertical points, then it becomes a graph that is a cone. If that is a cone, or if I connect all the points in vertical, then it can be a paraboloid. It can be a parabola. It can be a sphere. It can be some surface like this. Okay. If it is some surface like this, then again it has maxima and minima. Or if it is a cone, then it is undefined point. Or we can have saddle. Saddle in the sense that along x-axis it is going up, but whereas along y-axis it is going down. Can we see this? If this is origin, then along y-axis it is going like this, and along x-axis this is going. Can you imagine your 3D? One 3D surface where along x-axis it is going like this, and along y-axis it is going like this, like saddle on the horse. Saddle on the horse. So one side direction is like this, and other side it is direction is like this. So at that point, at the center origin, we have the critical point, but neither it is maximum, because one side it is minimum and one side it is maximum. So these are called saddle point. That also will see undefined point like cone or maximum or minimum. So these calculation we will see in the 3D also. So whatever we have done, calculation of the derivative and then equating it to 0 and finding the t value, here we will find the xy value. That's it. So then we will grow, and but we will have many bumps, because the difference between 2D and 3D is same as difference between earth and universe. Okay, so our mind works only in 2D. We know that here it is United States and here it is Canada, and if I keep going, then I would reach other side, that is India, China or Asia. So that is something that is 2D. From human point of view, 2D. So maximum human think in 2D. But 3D means whole universe. Okay, now you know the what is the difference in the surface area of earth and volume of the universe. How much the size is different, that much complexity it carries different when we go from 2D to 3D. So 2D and 3D is not one step ahead, it is far away, and far away beyond the helix count.